Okay, laws of indices. This video will summarize the laws of indices, the 6 of them, giving a note of all 6 at the end for you to keep, and an example of each. If you're interested in looking at where these laws of indices come from, then there's another short video you could have a look at that looks at that. Well, these laws of indices are to do with powers in numbers, the power or the index. So any number, x in this example, can be raised to a power. So x squared, x cubed. So here in general we've got x to the a. We call x the base in this case, and a the power or the index. And these laws are to do with what we do with these powers, and all the laws only work if the base is the same. It must be the same. So if the base is the same, we can use the laws of indices. Let's look at the first one. First law of indices says that a base x raised to the power a multiplied by the same base raised to the power b, we can just add the powers. So for example, if I've got 3 cubed and I multiply that by 3 to the power 2, or 3 squared, then because the base is the same, I can add the powers and I get 3 to the 5. It can also work with halves and fractions. So 4 to the power a half multiplied by 4 to the power a quarter, I can add the powers. A half plus a quarter is 3/4. Or negative numbers. So if the base is the same, and that's the key, in both of these examples the base is the same, I can add the powers. The second law of indices, if I've got the base raised to the power a and you divide that by the same base raised to the power b, I subtract the powers. So for example, 3 to the power 5 divided by 3 to the power 2, or 3 squared, is 3 to the power 5 minus 2, which is 3. You have to be a little bit careful about signs here. So 4 raised to the power 5 divided by 4 raised to the power minus 2, because the bottom number is a negative number, then I've got 5 rather is a power, minus 2 becomes plus 2, so I end up with 4 to the power 7. So just beware of signs when you're using this rule. The third rule, a base raised to a power a and then the whole lot raised to another power, I end up multiplying by the power. So for example, 3 cubed squared. So I take 3 cubed and I square it. What do I end up with? 3 to the power 3 times 2, which is 6. Again, the same rule applies whether it be a fraction or a negative number. I just multiply the powers together. The fourth rule, this is a rule that is used a lot in calculus, this idea of the inverse function. This one on the left here is an inverse function. 1 over means the inverse. 1 over. Or the inverse. I can rewrite that as the base raised to the power negative a. So that's where negatives often arise when we're talking about powers. So for example, 3 to the power 3 to the power 3 would become the inverse of 3 cubed. In other words, 1 over 3 cubed would be 3 to the power minus 3. If I have a number on top, so for example I have 4 over 5 cubed, for example, then the 4 would stay where it is and the 5 would come up to the top and be to the power minus 3. So that would be 4 times 5 to the minus 3. Useful in differentiation in calculus. I've got something like 4 over x cubed, as you will see. How do I differentiate something like this? I rewrite the 4 as it is, but then the inverse of x cubed, the 1 over x cubed, would be written as x to the minus 3. and then I would use the laws of indices to solve it. This 4 over x cubed can be thought of as 4 times 1 over x cubed. So in other words, we've got 4 multiplied by the inverse of x cubed, which I can write as x to the minus 3. So that's an interesting one, and it comes up a lot, particularly in calculus. This inverse being written as a negative power. As soon as I see an inverse here, 1 over, I write it as a negative power. The fifth law of indices is to do with roots. So I've got the bth root of x to the a. For example, the cube root of x squared. Again, I need to be able to use these to differentiate things like this. So the fourth rule and the fifth rule are very important when it comes to calculus. And what do I do with this? Well, the law tells me the power becomes a fraction, and the number inside the root, the a, goes on top of the fraction, and the root, b, in this case, goes underneath. The way I remember it is that roots go under the ground, so the root must go underneath the fraction here. So how do I rewrite this cube root of x squared? It will be x to the 3 over 2. Incidentally, I'm writing here equivalent to. These 3 lines mean equivalent to. So that's the same as that, in other words. It's not an equation, it's just another way of writing it. So another example, what about this one? Well, in this particular case, we know the power inside is cube, but what's the root? Well, laziness means that mathematicians don't bother to write this as a square root, and so there's a 2 there that's left out. So how do I rewrite this? I write it as think of it as a square root of x cubed, so that would be equivalent to x to the 3 over 2. The last rule of indices tells me that anything raised to the power 0 is 1. Any number raised to the power 0 is 1. So 5 raised to the power 0 is 1. And that's just worth remembering. Anything raised to the power 0 is 1. So in summary, we've got the 6 laws of indices that it's worth you trying to remember. When I multiply, so long as the base is the same, I add the powers. When I divide, so long as the base is the same, I subtract the powers. A base raised to 1 power and then the whole lot raised to another power, I multiply the powers. And then 2 laws that are particularly useful in calculus. What do I do with the inverse of a function? It becomes a negative power. What do I do with the root? It turns it into a fraction with the root going at the bottom.